This is lesson 8.4, Applications of Trigonometry. So far we know the three trig ratios and we can remember them using the acronym SOHCAHTOA. And I've listed those trig ratios here. We know that we use these trig ratios to find angles and sides of right triangles. Also a reminder of our Pythagoras theorem here, which will be important to solve some triangle problems. Now that we know all this, we can apply our knowledge to word problems and to application. Trig is very useful for calculating heights and distances, especially for things that we normally wouldn't be able to calculate very easily. So for example, if you had a really tall tree in your backyard and I asked you to measure how tall it is, well, you can't even reach the top of it. You definitely don't have a measuring tape long enough to measure it. Maybe you could climb up on a ladder, but it wouldn't be super easy to tell how tall it is. But from standing on the ground and using trigonometry, you can measure exactly how tall your tree is without actually climbing on top of it. Some new vocabulary that you'll see in different word problems are right here. The first is angle of elevation, and this picture comes from right from your workbook to help visualize what an angle of elevation is. This is the angle between when you're looking straight ahead and an object above you. So if you were this person here, and let's say you were looking up at like a bird in the sky, then the horizontal line that goes directly from your line of sight, and then as you look up at the bird, that angle that you create, that's the angle of elevation. So you can remember it because elevation is like going up. So it's the angle as you look up at something. On the other end, an angle of depression is the angle between looking straight ahead and an object below you. So let's say you were flying in a plane and you look down at some water below you, then that would create an angle of depression. So your normal sight line right ahead of you, and then your sight line as you look down at this object, that angle that it creates is the angle of depression. So angle of elevation is when you look up at something, angle of depression is when you look down at something. Another vocabulary word you might see is pitch. This is just another word for slope or a rise over run. Often people talk about pitch when we're talking about like a roof or a tent. So you might see that in some word problems as well. I've listed some steps about how to set up word problems with trig, but the thing is every word problem is slightly different. So it's not really even that useful to memorize step by step how you solve a couple word problems because you're going to see new ones every time. What you want to practice is your critical thinking skills that you can look at a word problem and ask yourself, what is it looking for? And what do I know? Set up a diagram to represent this information you do know, and then break the problem down so that you can get it into right triangles and solve using trig ratios. Always remember with our word problems, we want to write a concluding statement that answers the original question. So let's try this first example. A pilot is required to approach Vancouver Airport at an 8-degree angle of descent. If the plane is traveling at an altitude of 10,000 feet, at what horizontal distance from the airport should the descent begin? So this might sound like a lot of vocabulary and a lot of words, but just think about it. If you're flying in a plane, you stay at that same altitude for most of the flight. And at some point, when you get close enough to, let's say, Vancouver Airport, the plane starts to descend down. But how does that pilot know when they're supposed to start descending? This would be by using trigonometry to look at these different angles. They know they want to start descending when they have an 8% angle of descent or angle of depression. So that gets calculated in the with the technology on the plane, and then they can begin their descent down. The first step of solving a word problem with trig is always to draw a triangle or at least draw a diagram to represent the problem. So that's what I've done here. I drew a right triangle. This is my poor drawing of an airplane. And so the plane is flying up ahead or up top, and then down here is YVR Airport. And we know that the altitude of the plane is 10,000 feet. So that's why this right here is labeled as 10,000 because we're assuming that this is the ground. Well, YVR Airport is on the ground. So we're 10,000 feet above. What we're looking for is the horizontal distance from the airport. So from the plane to the airport, what does that horizontal distance have to be for when they start the descent? So that I've labeled as X because that's what we need. That's what we don't know. The other piece of information we know is this 8-degree angle of descent. So you might be tempted to put it right here where I've labeled alpha. You might say, oh, well, there's an angle. It's going from the plane down. That must be the 8 degrees, but not quite. we have to think about what an angle of depression, or in this case, angle of descent, means. You take the horizontal line of sight as if you were looking straight ahead, and then you look down at the object that you're looking at, and that creates the angle of depression. So that's why I've drawn this dotted line out, because that represents the horizontal line of sight directly ahead of the airplane. So it's actually slightly outside of the triangle where this 8 degrees is. The good news is between this dotted line we've drawn and this straight line up and down representing the vertical height, this is a 90-degree angle. So we can actually find this angle quite easily, which I'll get to in a moment. This step is the hardest step. Just setting up the diagram is the most difficult part. And again, you're not going to know right away what it's going to look like. I would definitely start by drawing a triangle and then try labeling it with the things that you do know, and then you want to look at the things that you don't know. Like all word problems, I have a variable that represents an unknown, so I have a let statement to assign a variable to it. So that's why I've written let x represent the horizontal distance, which I've labeled right here. So as I wrote in green, the green kind of represents my thought process. We don't have any angles in the triangle, so we can't solve for x yet. Yeah, we know this is 90 degrees, but we don't know either of the other angles, which is a problem. So I can't solve for this. That's why I've labeled this as alpha, because if we can find that angle, then we can use our trig ratios with this side length to figure out our x. So the first step is to find alpha. And this is actually not too difficult to do. It's just 90 degrees minus 8 degrees. Because again, this makes a 90-degree corner. We know a small piece of it is 8 degrees. So the remaining 82 degrees has to be this angle alpha. So that's what I've written out here. Now that we know that alpha represents 82 degrees, looking from that angle, we have the adjacent side length and we need the opposite side length. So that means we have to use the tan ratio. So tan of alpha is the opposite side over the adjacent side. I replaced alpha with 82 degrees because I just found that, and I replaced my side lengths as well. And then to solve for x, I just multiply both sides by 10,000. And then on my calculator, I round to 0 decimal places and I get about this many feet, 71,154. Again, always finish your word problems with a final sentence that answers your original question. The question wasn't asking, what is x equal to? The question was asking, when should the plane start their descent? So that's why I wrote, the plane should start descent when they're 71,154 feet from the airport. Okay, let's try another type of example we might see with some of our new vocabulary. A carpenter says that the pitch needed for rain to run properly off a roof is at least 4 to 12. Find the angle the roof makes with the horizontal. So this is that new word pitch. Remember, this represents our slope. So it's saying the slope of the roof, it has to be a certain steepness so that the rain can run off properly. If you had a perfectly flat roof, anytime it rains, you might have buildup of rain on top of that roof. But if you make it at an angle like a triangle roof, then the rain can run off. And it's saying it wants this pitch or this slope to be at least 4 to 12. So first, it's always the first step is to make your diagram, which usually involves triangles when we're working with trig ratios. So I've drawn my beautiful house here, and this triangle, that's the roof of this home, and we have our little door. So if it says that the pitch is 4 to 12, what that actually means is that the slope is 4 over 12. It's just kind of a fancy way of saying slope is 4 over 12. What we know about slope is that it's rise over run. So really what we've identified is that the rise is 4 and the run is 12. If we're looking at this roof as it is, this is not a right angle triangle. This is like an isosceles triangle. But if we split it in half, like I've done with this dotted line here, then we have two right triangles that are equal. If we're looking, what angle we're looking for is find the angle the roof makes with the horizontal. So that would be this theta right here, because that's the angle between the roof and the horizontal of either the, like this horizontal is the same angle as the horizontal on the bottom. It's just it's a flat roof. So we want to find this angle theta here. How I knew to label this side length as 12 and this one as 4 is from this corner, the steepness or the pitch of this roof has a rise of 4 and a run of 12. We know how to graph with slope by counting a rise over run, and it's the same idea here. So the up and down movement, or the rise, is 4, and the side to side is 12. So that's how I need to label those like here and here. So yes, we have this whole house going on, but really what we only care about is this tiny part here, which is the right triangle. And actually we have everything we need. From this, we can find this theta because we have our opposite side length and we have our adjacent side length. So that's the math that I've done over here. We would want to use tan because of opposite and adjacent. So tan of theta would be equal to 4 over 12. To get theta on its own, we bring the tan to the other side as inverse tan. We put this in our calculator and we round to 1 decimal place to get 18.4 degrees. We always write a therefore statement, so therefore the angle of the roof is 18.4 degrees. As I've said here, the hardest part is setting up the diagram, and it's going to take practice. You're not going to know right away when you look at a word problem necessarily what you're looking for or what you have. But always start by drawing the diagram and talking your way through the problem. What makes sense? What do I know? And what am I looking for? The last problem we'll go over together. The equal sides of an isosceles triangle, it should just be triangle, are 30 centimeters, and the third side is 36 centimeters. Determine the 3 angles of the triangle. First step always is to draw our diagram. So this is an isosceles triangle. That means 2 of the side lengths are equal and 1 of them is not. So I've drawn it. I'll say these 2 side lengths are the equal ones. They're both 30 centimeters as stated in the problem, and the other side length is 36 centimeters. These lines, remember, those represent that these 2 side lengths are equal. We want to know the 3 angles of this triangle. So I've labeled it theta 1, theta 2, and theta 3. The problem right now is that this is not a right triangle. We can't use trig ratios if it's not a right triangle. So what we have to do is transform it into right triangles, which we can do by cutting it in half. So it's the exact same triangle with the same side lengths, but I've just drawn this dotted line down the middle. So now I'm dealing with 2 right triangles. This is still our theta 1. That angle hasn't changed. The only thing that's slightly different is that when I'm looking at this right triangle, this base is going to be 18 centimeters, not 36, because it's half of it. This would be 18 centimeters and this would be 18 centimeters because they would add to 36. So we have this new right triangle where the hypotenuse is 30, the adjacent side is 18, and we have our little theta 1 here. So we can start with that and solve for theta 1. There's my let statement on the side. I just said let theta 1, 2, and 3 represent the unknown angles. So I know that I have to use the cos ratio because I have adjacent and hypotenuse. I substitute those side lengths in so that I can find theta 1. I use my cos inverse to get the cos on the other side and isolate for my theta. And when I put this in my calculator, I get 53.1 degrees. So I found theta 1, and I still need to find the other 2 angles. Technically, I've also created a right triangle here, so I could solve for theta 2, which is in this corner, using the same method. But that's actually a bit of a waste of time because what we know about isosceles triangles is that in this case, theta 1 and theta 2 have to be equal. Just like these 2 side lengths are equal, these 2 angles are equal. So that's what I've written right here, is that theta 2 is also equal to 53.1 because it's an isosceles triangle. If you forgot that piece and you did repeat this process to solve for theta 2, that's totally fine as well, but you should get the same answer because you're dealing with the same dimensions. You have an adjacent of 18, a hypotenuse of 30. And then to find theta 3, this is maybe a bit of a problem because this, we don't have a right, if we're going from this angle, we don't have a right angle, but we don't have to use trig ratios to solve for our third missing angle because we can just add up. We know that all the angles on the inside have to add up to 180. So if we do 180 degrees minus the 2 angles we already found, we get that the third theta 3 here should be 73.8 degrees. And then I write my final sentence with my 3 angles, and I've solved the problem. So in summary, as we're word problems are slightly different. So instead of memorizing how to do them, you have to learn how to critically assess a problem, even if you've never seen that exact one before. The most important and helpful step is sketching that diagram to represent the situation, and then label it with your knowns and unknowns. Always ask yourself, does this make sense in the context of the problem? That helps you identify if you've made any mistakes along the way. And always write a concluding sentence that answers your original question. This is how we can apply trig ratios to solve word problems in the real world.